Hello, everyone. In this lesson, I wish to review about one-sided limits. Okay, why one-sided limits is so important and it's often tested. It's all because of this, you see that on the flashcards, right? There's one important result, a theorem, we can call it, is that I'm going to type it. If the limit exists, okay, suppose we have a limit. When x is approaching a, right, we know that definition, right? A is not necessarily in the domain of f. If this limit exists, and that is equivalent to say, if and only if. If and only if the limit from the size, there are only two sides, right? This is where we're working on a, the input is one dimensional, the output is another dimensional. So it's a limit from the left. Okay, be careful. You want to use the notation properly. If you don't use the notation properly, you convey an entirely different meaning. Okay, so you must make sure you use the right notation. As we mentioned in class, notation, because your work will be judged by the work you show. Okay, so the other limit is that the limit of, x approaching a from larger than a. So these are the two, this is a one side limit, and this is the limit from the left and limit from the right. What I mean is that x, the input approaches the number from smaller than the number, and the other one is, the input approaching number from larger than the number, and these two must be the same. So oftentimes this theorem is, even though the if and only if it implies that this limit exists and it is L, and the second limit exists and it is L, and these two limits are the same. So that's this identity, this piece, hold on. I think I deleted something I should not have deleted. Okay, so limit from the right. Okay, limit from the right. So these two, so this actually implies three conditions. Okay, implies three conditions. That three conditions are, okay, so I'm going to put it on this side. I'm going to put a table so you know what I'm talking about. That implication, it has three conditions. The first one, meaning, right, that this limit exists. And, okay, the second condition means that this other limit exists. Okay, it also exists. And thirdly, they're the same. These two are the same. So implies three conditions. They imply three conditions. So, and the opposite of these three all happening at the same time, it becomes a very complicated situation. Okay, it could be that one does not exist, right? So if you let's just use our logic to think about all the possible cases, right? So this implication, I'm going to bring this back up. I want you guys to just to think about the implication of the opposite of it, right? If this is true, then if and only if, right? I'm just going to switch the direction, if and only if. If and only if, I just switch side. Right? Just switch sides, still the same theorem. So that implication, so what is the opposite of it, right? So the opposite, the false case, the opposite of 1, 2, 3 can happen in the following way. Okay, it could be that A does not exist. Okay, these are very useful stuff. Okay, this is false, does not exist. Does not exist. If this does not exist, that means 1, 2, 3, all they must be true. If one is false, the entirety of the side is false. And we can, if the first one is false, we can say that limit does not exist. We can say this piece does not exist. You need to do no more. You need to do no more. Okay. Are there such cases? Of course. Okay. And you will encounter the case. Second one, it could be that this one does not exist. The limit from the right does not exist. In that case, you don't have to do anything. You can just declare that limit does not exist. Okay? Okay. Cases that limit does not exist, right? So the cases that the limit does not exist could happen in the following way. Case A, case B, and A could be case C. Case C is that 1, 2, 3 are true. 1 and 2 are true, but the third one, is not true. Okay, the third one is not true. Both exist and 3 does not. Right? Both exist, but the limit does not exist. Therefore, the third case that the limit does not exist. So all of these different cases, A, B, C, and there well to be, there could be D, right? There could be D. So let's figure out what will be the D. So you start to think logically, all 3 statements must be true. What is the opposite of A and B and C? Okay, so this is actually related to table. Okay, so let me just give you a little guideline so you can see how many different kinds of questions we could have. Okay, limit does not exist, right? So I'm just enumerating a few. So D could happen so what? One exists and the other one does not exist. So there could be another case. There could be another case. This one does not exist. In this case, as I would say, you don't have to even check these two. But therefore, that's why it's just, if one of it does not exist, then the whole limit does not exist. So this case, it could happen, but you don't need to do that much work. Right? Because if one does not exist, the entire limit does not exist. So I will put D in the category of the A. Okay? So similar situations, and let's see if there's another situation we have not considered, right? If this exists, and the third C is a case that both exist, but they're not the same. So you can see cases there could be more cases. In those other more cases, you don't need to check them all. Okay, but what you want to do is that you will find that one single reason or minimal reason to demonstrate that limit does not exist. And that will be good enough, right? You don't have to check all 3. Because if this is not true, then the limit does not exist. If this is not true, then the whole limit does not exist. You both exist, and then if they are not the same, then limit does not exist. Does that make sense? I hope that makes sense, right? So let's look at them with some examples. Okay, we certainly have seen some examples from our homework, right? The homework, this is the homework in week 3. Okay, week 3. We've done this one, and I'm going to go over this one to explain. And you can categorize, right? You can categorize. Let me gonna put it here. One-sided limit, right? So I just want to try to keep the screen a bit cleaner. You see, at point 1, the limit from the right and the limit from the left, right? The limit from the right, which is 1, right? So you're gonna have x approaching 1 from greater than 1. And that is not the same as the other because 1 and 2 are not the same. So this is the case of the C category, Both limits exist, but they're not the same. So you have to learn, you want to learn the language as how to speak the language, quoting the theorem to get the points. As I mentioned, the more you quote the theorem, the more points you're getting. Okay, so I think most of you have got that. You guys got that. And both sides limit exists. That's what happened on 0, right? On 0, in the case, when x approaching 0, then the limit is 1, whether you do it from left side or right side, right? So this is a problem to 1. So to 0, you can use, and both sides, they have the same limit. So you can use this theorem to demonstrate. So we did that example in class, so I'm kind of quickly go by it, right? Let's look at another situation that we did in class, right? There's also the consideration is whether the function is defined at the point of consideration, right? For example, f of 1 is defined, but f of 0 is undefined, right? And you were being quizzed on this question. So let's look at the next one. The next one is the point of interest is 2. The point of interest is 2. And the limit from the left and the limit from the right are not the same. Okay, so let me make this font a bit larger. No, hold on. Wait. That's a flashcard. Okay. I'm trying to make this a bit larger. I hope you can see that's 2 plus, that's 2 to the power, 2 shoulder minus. That's the from left to from right, right? From the picture, it's rather, it's pretty straightforward to see, but you have to express yourself properly. So when you express it, you use the proper notation. Okay. Number 4, that is the situation. Number 4, number 5 is the situation that the graph is not given to you. Okay, the graph is not given to you. If the graph is not given to you, number 1, you can use the graph. You can make your own graph, or you don't have to use the graph. You can work it by yourself. Okay, just make sure you understand the piecewise function. Okay, so I'm going to work with you without seeing the picture. Oh, okay, so here I'm going to make the picture a bit larger. Okay, so in that case, right, so it asks us to graph the function. Okay, it asks us to graph the function. The point of interest here is -1. Can you guys see that? I think I'm going to copy and paste this question. Okay. Just remember, most of the time you're dealing with these 3 cases, okay, A, B, C. Okay, and I'm going to copy and paste the question because I found these are not very clear. Okay. So the function, so how do we graph the function? I'm going to talk about how we graph the function. Okay. One way to graph the function is the following. Of course, you should do it piece by piece, is you need to be very clear about the domain. Okay, what is the domain of this function? Less than 1 from -1 to less than -1 from -1 to 1. So this function actually is defined, function is defined everywhere. The domain is all real numbers. Okay, so 1 plus x, excuse me, 1 plus x, excuse me. Okay. If x is less than -1, excuse me. And the second function is x squared. If x is greater than or equal to -1 and less than +1. And the third case is 2 minus x. Okay, 2 minus x. How do you graph this? The common mistake, I'm going to first point out the common mistake. Okay, so here's this is x is greater than or equals to 1. Okay, the common mistake, if you don't understand the piecewise function, it could be something like this. Okay, f of x, we do 1 plus x. I'm just going to show you the graph, right? 1 plus x. Okay, hold on. 1 plus x. And on this graph, and then we do the x squared, right? And then we do the greater than, that's a 2 minus x. 2 minus x. Wait. Okay. This is the kind of picture, even though I don't see this mistake with great popularity, but this is a terrible mistake. This is a terrible mistake because all of these functions, it's no longer a function. Okay, this is no longer a function. It doesn't pass vertical line test. It doesn't pass the vertical line test, right? If you draw a vertical line, it crosses the curve 3 times, right? It crosses the curve 3 times. So you need to do it piece by piece, piece by piece. Okay, so you need to be very careful. So if you do this kind of picture, you know you're getting 0. Okay, and it doesn't help you at all. It doesn't help you at all. But what can you do? Right? What can you do? You say, oh, my function, my calculator may not have that function. Well, you just have to follow the rule. Okay, so I'm going to do a little bit, I'm going to try to see if I can help you by imitating what you can do on paper, right? And how we can make it work. How we can make it work. Okay. So how we get this vertical line here? This vertical line, that's a mistake. You see, these softwares, they're not perfect. They're not perfect. Okay, good. So this is a goal. Okay. Okay. First, you need to recognize less than 1, there's a rule. So which function is less than 1? Less than -1, I'm sorry, less than -1. That's 1 plus x. Okay, so I'm going to make a little adjustment to the view. Okay, it looks like if I put a negative between -5 to +5, -5 to +5. Right? So what you need to do is that you first need to know which one is which, right? Which one is which? This one Okay, so this piece is 1 plus x. And of course, this one is x squared. And the last one is 2 minus x. Okay, and then you need to get ready to use an eraser. Okay, to use an eraser. And for me, I'm going to have to cover some of this stuff, right? So 1 plus x is used, this rule is used up to less than -1, not including -1. So this piece is used, but not including -1. So I'm going to have to put a little circle here. I'm going to have to put a circle here at a -1. Right? This circle is a little too thick. Okay, so I'm going to redo it. There. So I'm going to have a circle here, right? Indicating that -1 is not included on this rule. And how about the rest of it? The rest of it, I'm going to have to cover it up. Okay, let me see if I can cover this. Well, I'm going to have to cover this. Okay, I'm trying to imitate what would you be doing if you do it on paper. Okay, so I'm doing this. I'm doing this cover up. You can see it's not pretty. It's messy. Okay, so I'm erasing these things. You see, I'm making these go away. I'm imitating your action. So you're probably using an eraser, right? So this rule is gone, right? Let's see. I can use okay, I'm just trying to cover this up. They're gone. Okay, so that's a good coverage. Okay, so now between -1 to +1, not including +1, is the parabola. So parabola, right, it's only from -1, including -1, all the way up to +1, not including +1. Okay, so what do we do here is that we're going to have to erase that piece. I'm erasing that. Okay, I'm erasing that. I'm erasing that. And beyond 1, I'm erasing it. I'm erasing it. I'm just gonna cover it. Who cares? Okay, I'm gonna mark it again. Okay, so move this over, right? But we need to be careful. At -1, we should have a dot. We should have a dot. We should have a dot. And I'm gonna make this dot right here. Okay, this indicating when we draw a vertical line across -1, it meets the curve at exactly one place. Okay, so this is but for -1, that's the case for -1. How about for +1? Or for +1, it should be a circle on the parabola, squared, right? And now finally we come to x greater than or equals to 1. And all of these must be erased. Okay. Let me hope I can see erase it. Yeah, I'm erasing it. I'm using the software to erase it. Okay, so forgive me, it's not perfect, but I'm imitating what you will be doing on paper with pencil, eraser. So be patient with me. Okay, but includes one, right? So it had a circle, so now it's a dot, but they happen to be on the same point. Okay, they happen to be the same place because when x equals to 1, 1 squared is 1. When x is equals to 1, you're using this rule is 2 minus 1. So this circle now can be removed. Can be removed. Okay. So now I'm just going to remove it. Oops. Okay. I'm going to move that. Erased, erased. So this will be the proper picture. If you do it on paper, okay, my imitation may not be the perfect one, but this point, obviously, it should have a dot there. But you know this dot is on 2 minus x, right? So let me mark it again. So this piece is 1 plus x. Excuse me, I'm going to change the color. I'm sorry that I choked, so now it's so 1 plus x, right? So that's the rule. And this piece is x squared. So that's piece 2 minus x and from 1. So that would be the proper picture if you are to graph by hands. Well, on the exam, often you will have to do this, right? So you need to know, make sure you don't make the mistake we pointed out earlier. But once you have this graph, then it's pretty easy for you to figure out all of these, questions. Okay, all of these questions. And that's how you do it. Just make sure you use the right notation. You just use the right notation. Okay. And now if I remove everything, because this software seemed to give me a picture, right? So I'm going to show you that picture properly, and then we finish the question. We're going to finish the question. Okay, so we're going to clear all drawings. Don't make this mistake. Okay, it's a terrible mistake. It guarantees to get you lose points. Okay, so now I'm now going to use this picture, and I use this software to generate the picture. So this will be the proper picture, but I need to add some stuff on it. Okay, obviously you can see there's missing circles and dots, right? They're missing circles and dots, and I'm going to work on that. So -5 there. Okay, and interesting. This software sometimes just play game with me. There we go. Okay. I need to do some additional modification, well, adding certain things, right? So -1, I need to put a circle there, right? You don't have to use this software. You primarily do it by hand. Okay. No, cancel. Okay, so I add a point, which is at -1, 0. -1, 0. That should be a point with a circle. So we indicate, okay, so maybe I can even make it a red color, right? Because I'm doing the demo in this class, in this recorded lecture, so you can see now for hosted 1, we're going to put a dot right on top. We're going to put a dot right on top. So that's -1, +1, and it's a point. It's a dot, right? And here I just leave it like that. Okay. So you know how to sketch it. So now let's look at how do we find these limits, right? How do we find these limits? I'm going to make the fonts a bit larger. First thing first, you want to use a notation properly. Okay, if your notation is wrong, you're getting no credit for what you've done. Okay, so when we look at x approaching -1 from smaller than -1. Okay, so let me make the fonts larger. There we go. So you see all the signs, right? F of x. Don't leave this place empty. Don't leave it empty. Okay. So you will be observing right? The limit of the function. Let me make adjustment to the graph so that we can make it easier to explain to you. So, yeah, I think that's better. Okay. So when x is approaching -1, in your mind, you don't have to mark these, but in your mind, you know what I'm talking about. Okay, so approaching -1 from smaller than -1, right? So that limit, you approaching -1 from smaller than -1, that means x is less than -1. So you'll be using this rule. Okay, we'll be using this rule. So that will be equals to, you're gonna replace f of x by 1 plus x. You can see at this point, whether you have the graph or not, it actually doesn't matter if you know how to read the piecewise function. And this is polynomial, it's, you can substitute. So 1 plus -1, direct substitution, it equals to 0. So that's how you can show your work. Okay. And limit from right. Limit from right. Okay. That's the second question. Okay. Limit from right. Limit from right, which is going to be positive sign. You must make sure you write it down properly. And when we approach -1 from larger than -1, and this rule is used, right? This rule is used, x squared, right? Because including, this is from greater than -1. So this limit, so when you show work, you want to write it down. You want to show your teacher, the second rule is used, which is x squared. So it's a direct substitution again. So you have a -1 raised to the power squared, and that's equals to 1. Okay, for question number 3, this is question number 1. For question number 2, right? And question number 3, okay, is asking for limit, right? The limit removing the size sign, okay? When x approaching -1, f of x, never leave this place empty. Okay, then what do you say? You can say it does not exist because, okay, because I can use that symbol you like. Right, let's see, do I have that symbol? There, because, right? Because of what? Because these two limits are not the same. They're not the same. Ideally, you show your work like that, because, right? So which category of this question is? So the limit does not exist. Both limit exist, but they're not the same, right? Both limit exist, it does not same. So this kind of question show up, quite often. Okay. And for +1, oh, it also asks for f of -1. For f of -1, you're going to be using, okay, so this is number 4. F of -1, it's basically, you draw a vertical line test. You draw a vertical line. Oh, this is too thick, sorry. Okay, you draw a vertical line across the curve, this piecewise function, across the curve once, and that's the value, okay? That equals to positive 1. You finished. 1, 2, 3, 4. Okay, and for 5, 6, 7, it's the same. It's the same rhythm, but it's in the neighborhood of 1. In the neighborhood of 1, right? And then you continue that process. You continue that process. Okay, so this time is 5. You see the notation, the usage of notation, and the proper expression. When you use the right notation, it really helps because you don't have to explain so much using words. And x is approaching 1, right? So here, f of x, you just take your time doing it, right? When x approaching 1 from smaller than 1, right? From smaller than 1. Well, smaller than 1, then you'll be using this rule, right? F of x is going to be using the rule of x squared, right? So x squared. And that will be direct substitution. You're going to get 1 squared and equals 1. Number 6, right? Approaching 1 from larger than 1, right? Larger than 1, right? And that will be a different rule. Larger than 1, from larger than 1. You need to take care of all these little details. Yes, this time the rule is 2 minus x. Okay, so 2 minus x. Okay, and you substitute, direct substitution, 2 minus 1 equals to 1. Right? Number 7, right? It asking for limit when x is approaching 1. Right? Positive 1. And this limit exists because limit from the left and the limit from the right are the same. So this case is really about making the narrative very smoothly demonstrate that you understand the theorem, which is equal. These two are equal. Right? So this example on the homework, this is how you show your work. This is how you show your work. Ideally, in the ideal world. If you want to get full credit, if you do this, you get full credit. Okay, of course, number 8, f of 1, what does that equal to? F of 1 will apply the rule 2 minus x. So it's a 2 minus 1 equals to 1. Okay, that's all you need to show. That's all you need to show. Okay, so whether you have the picture or not having the picture, you need to constantly refer to the rule, and that's all you need to do. That's all you need to do. Okay, limit from the size. Okay, and the other one is, I think this example we're going to use it again when continuity is studied. And I'm going to show you how we would do this one. Okay, so first, I'm going to do the graph after. Okay, so I will show you how you can do it without doing the graph. Okay, without doing the graph. So copy the question. Copy the question. You can see I prepared some other questions for you. Okay. You will surely have these kind of questions on your midterm exam. Okay, so the sooner you get it, you get it done, you understand it, you know how to deal with it, it's better. So 1 plus sine x if x is less than 0. If x is less than 0. And this one is cosine x. If zero is less than or equals to x less than equals to pi. And the third case is sine x. If x is greater than pi. Greater than pi. Okay, so that's the function. So we're not going to do graph. Not doing graph, we just go straight to it, right? And it's still testing us about these concepts, right? That one single concept, which is we talk about on the top. It's really just about this piece. It's really about this piece, right? And now we look at limit, right? Limit of x approaching 0 from smaller than 0. From smaller than 0. And we're working with f of x. What do we have? Right, less than 0, well, x approaching 0, meaning x is less than 0. So we will be applying this rule, right? 1 plus sine x. 1 plus sine x. Right? Direct substitution. So you get 1 plus sine of 0. Sine of 0 equals to 0. 1 plus 0 is 1. So limit from the left. Limit from the right. Right? As you're getting better, you're just doing it faster. I'm going slowly. If it's too slow for you, just fast forward. Okay, fast forward. And I even recommend you pause this piece of lesson and you just try yourself. And I'm sure you've done your homework, and this is also the time you compare your work with mine. Okay, so for x approaching 0 from larger than 0, which rule do we apply? We apply the rule in the middle. So cosine x, right? And then direct substitution again, cosine 0 equals to 1. And there we go. The third question that is asking about limits of the function at when x is approaching 0, right? And there you go. You can say, you can use a different order, right? Because you can say because. Where's my because? I forgot where it was. Wait, not this one. This one here, because, right? You can say, you can change your way to say where, because you know what is the centerpiece we're testing you guys on, right? You just make a complete nice narrative. And these two are the same. Okay. These two are the same. And if you want to make it equals to 1, then what do you say? The limit of f of x when x is approaching 0, f of x is equal to 1. Quoting the theorem, we're quoting the theorem. Okay, you should have the flashcard of the theorem right by your side, right? So that answered question 1, 2, 3, 4. Right? Number 4, f of 0. F of 0 is equal to, when x is equal to 0, which rule do we apply? Cosine x. So cosine of 0, that equals to 1. Okay, so this function, actually, I think we're going to use it for continuity as well. And number 5 for 5, 6, 7, 8, right? Done similarly. Number 5, this time is approaching pi. It's in the neighborhood of pi. Okay, so limit as x approaching pi, okay, from smaller than pi, you can see these notation are very concise, very concise. You see the notation, you know what to look for. That means x less than pi, approaching pi from left of pi. So that means we're going to use this rule. Okay, we're going to use this rule. So limit sign, we'll keep it. And we're going to use the rule in the middle, cosine x, right? Direct substitution, cosine is equals to -1, right? Number 6, limit. If you write it down by hand, you can do much faster, okay? Approaching pi from larger than pi, right? F of x equals to, and this time, the rule we're applying is when x is larger than pi. When x is larger than pi, we use this rule, sine. So sine of x and approaching and direct substitution sine of pi equals to 0. And there we go. Number 7, what do we say? The limit does not exist, right? Because limit from left, the limit from the left, right, and they're not the same. Then you can also say because, right? I can pretty much copy these, just make some minor changes if you will forgive me, right? I just make it a little faster, right? Because this two limits are not the same. Then we say what? Then we say the limit as x approaching pi on f of x, what? Does not exist. You see, the grammar and the narrative are very similar, very similar. So it's pretty easy to master. It's pretty easy to master. That's my opinion. I think you guys are going to master this in no time. Okay. Now, f of pi. Last question. F of pi. What is f of pi? Well, when x equals to pi, right? And the second rule, cosine pi. Cosine pi equals to -1. You're finished. So 1, 2, 3, 4, 5, 6, 7, 8, right? We have one case. That is, right? We have two cases of cases. One case that the C case, right? And the other case is that all of these are true. Well, we're really just testing you guys on these things. Okay. The next one is that the next category is because of the absolute value. Okay, I prepared some question and I prepared a guide for you guys to practice. So I like to start with this. Some of you guys still have some difficulty with absolute value. So I'm going to kind of start from the absolute value situation. Let's see, how long has it been? Maybe I should make a different one. Yeah, let me make a different one. Okay, because I don't want these lessons to be too long. Okay, next time. Okay, thank you for watching.